Hello everyone, welcome back to the channel. Today we are diving with the topic whether the patient has heart disease or not. This data set comes from the healthcare domain. I have downloaded the data set from the Kaggle. I have already shared the link here. You can also download it. I made a small changes and we will do a lot of customization using this data set. Okay. And in this, the original data set link is this one. Even on the Kaggle, they are using it from here. But when you use this resource to download the data set, it contains actually a lot of files. And you can only use a Cleveland database. Okay. Here, you also need to make a changes in the column name. So I have picked up from the Kaggle. You can also download the data set, which is the polished one, this one. Okay. But the original link is this one. And they have given the very good data dictionary detail here. Whenever we are working in with the healthcare domain dataset, it is the most important part. Although it is important for every like your domain, whenever you are working with any data set, it is important to understand the data dictionary. I always recommend this thing to my every student. This is very important. If you don't know the meaning of the feature, why you are using it, there is a no use to do the analysis, because you won't be able to understand the statistics or the relationship between the features or with the target if you don't understand what is the meaning of that feature name. Okay, I have copy and pasted the like some dictionary here. Okay, and we will go through it quickly, but if you want to take a deep dive, this is the link. Okay, so I have already shared this link here too, so you can go there and you can use this website to understand it at a more deeper level. Okay. Okay, so the very first thing is we know now we have a data set from the healthcare domain. Number two, I have shared the polished data link which you can download and start the analysis with me too. Even you are watching the video, you can pause, you can write the code, you can understand the process and you can replay the video. Then you will learn more. Okay, I know it will take your many like the hours, but believe me, if you are doing following me by watching this video, by downloading and writing the code with me, then you will learn and understand the process uh, definitely. Okay, more than just watching the video. Okay, believe me, just try it one time. Either it may take you a half day or more than that. It depend upon your speed. You can take a break in between, right? But once you finish this notebook, you feel you have learned something. Okay, so by watching only the video is also is then doing the like the project with me is more beneficial, okay, for you. So this is my recommendation. Rest choice is your. Okay. And then here, look at this one. So this is the data dictionary. I have copy and pasted the few column like the data dictionary. This is age, this is gender, male, female. They have denoted it with the 1 or 0. Chest pain type. This is a 4 type of the chest pain based on what we will decide whether the patient has heart disease or not. Resting blood pressure. This is this one. T rest BPS. Okay. If you don't know what is this, you won't be able to understand, right? So that's why you need to look for the data dictionary. If you know someone who is working in the healthcare, right, they have a good knowledge about this domain, then you can talk with them, their domain expertise, right? They work daily, they know about it, they see the reports, right? They can give you the more information. And if you are saying, Nija, I don't have any stakeholder, I don't have any domain expertise, then Google is going to be your domain expertise. Just to find out what features are important, what does it mean, can it be, will it be helpful when I'm using it for the model? It will give you some sense, right? Just try to understand the meaning. I'm not saying just spend 2 days, 1 day whole, just spend 5 or 10 minutes to understand about the feature if you don't know what is this meaning. Okay. Although I have already shared this link, you can take a deep dive in this. Okay, so it is telling about all features. What does it mean? Okay, and then this is the cholesterol level. This is fasting blood sugar. This is your resting electrocardiographic results. Okay, this is the maximum heart rate achieved by exercise induced angina. Okay, Tholic. So this is old peak, this is a slope of the peak exercise ST segment, CA number of major vessels. This is the most important actually. Okay. And then this is the target, what we want to predict. So this is just a quick information about the over data set, that is a heart disease data set. They have removed the patient's name due to the due to confidentiality. So now we will move ahead. Here I have embedded the all my YouTube playlist. If you are interested, you are a beginner, you can start with the Python. This is all only and only this is a practical example. It does not contain any theory. Okay, so you can start with the first Python, then follow the beginners, and then intermediate, advanced, and then you can also, if you're looking for the deployment too, then you can use this one. Okay, although even today, what we are going to do first, we will start with the analysis, then the deep data visualization and analysis, and then we will apply the three different models: a logistic regression, XGBoost, and random forest classifier. And then on top of that, I'm going to teach you today or discuss with you the how you can deploy your project. If you are the first time you are watching this video is going to be most beneficial for you. Okay. Although this video is perfect for everyone because I'm going to show you the different graphs today and the deep analysis and three different type of confusion metrics and then deployment too. So this is a complete project. Okay, don't go away. Don't go anywhere. Stay with me till the end of the video. Pause the video, write the code, download the video like this one. Even if you want, I will share this notebook with you. You can download the notebook, open the video in one window and this notebook on the right side. Just keep on running the cells. It will make more sense to you. You can embed your code to just create a new cell, type give the heading your code, right? And then add it. So this is the best way to learn and implement it practically. Believe me, you feel the difference. Okay. And then here we go. Here we are just importing the over four mandatory libraries. Pandas and NumPy are the libraries we use for data manipulation. And your matplot and seaborn is for your visualization, graphical representation. And this is we are importing because I don't like actually the warning when it shows. I hate it because it takes my so much space. So I need to scroll a lot to see my actual output actually. So I don't like it. I always embed this. Okay. And then we are loading the data set. I'm using the Google Colab. If you're using your local environment, then you can change the path here. Okay. So this is the file I have uploaded. Okay. And then we will make a copy of the original data set. Okay. There are some reasons actually why I always make a copy. I have shared it in a detail actually one of my video. You will find it. So here I will give you the a recap. Number one, whenever you are making any customization, then never ever make a customization in your original data set. There might be we do some mistakes or something happened which cause the data leakage. To avoid that, always make a copy. Number two, if you are collecting the data from the different two or three different resources, you do a lot of hard work, right? You are spending so much time for the collection of the data because collection of the data is the most, I will say, the most time consuming task. Believe me, whenever you work in the real time, you are getting the CSV file right now we are doing, right? But I will definitely make a one video where I will show you how you can collect the data from the different resources using web scraping. I will make a one video how you can collect the data using web API and web scraping too. Okay. So it takes so much time because you will face so many problems during the collection of the data, especially when you are using the web scraping actually. Okay, there are multiple kind of the issues come up. It might take you 2 days, 3 days. If it's a big data, it might take 15 days. So we don't want the originality of that data set. That's why it's a wise decision to keep it safe. Okay, although I am not saying you will not keep it safe, a different file on your system, but make a copy it here too. Okay, so that's why, because sometimes we need to recall our original data due to some mistakes or we want to go back to our analysis again. Okay, so that's why this is important. I have told you, shared with you the importance. So please follow it. Okay. And then here we have exploratory data analysis. This is a heart disease. We are just looking at the using the head method, what kind of the data we have. Now look at this. This is target. This is 1 or 0. 1 means patient have the heart disease. 0 means no. And these are the other features. You can see CP. This is not a numerical. Okay, they have already converted it into the label encoder. These all are categorical actually. This is a gender, male, female, right? If we go back here, 1 means male, 0 means female. So try to understand this data set. When you are at a beginner level, students often does this mistake. Whenever they will see this kind of the result, they will be very happy. Oh, every data type is integer. If they found any missing value, let's say in this column or maybe the CP, they don't take care, they don't care. This is not numerical data type. The feature is coming in the integer data type because they have given us the polished data. Okay, but in real, this is categorical, right? Because it is a label encoder 0, 1, 2, 3, 4. This is label encoder, this is not integer. If you like are totally beginner, and then if you want to understand about it, then you can watch my Python playlist, okay, and stat playlist. I did not share the link for the stat playlist here, but you will find on my channel where I am explaining in detail what is ordinal, nominal, continuous variable, categorical variable. Okay, so you will have the very good idea. Okay, so this thing you should keep in your mind. This is not related to restricted to this data set only. It you might found that this kind of the data in any other domain too. Okay, but I'm just highlighting the very fundamental and the basic points, so it should strike your mind why you are looking at the data set using the head method and what you should look. Okay, because we always ignore this thing, right? Whenever you are using the head, you see, oh, this is the data set, that's it, and you scroll down. But this is not the right way. Understand? That's why head method is there, right? They have built it. Now we will look for the info method. This is very good method. Here you can see the total number of records. This is 303. You have a total number of columns 14, right? And it is telling you the what data type, right? Integer. Now look at this. This is gender column. It is showing integer. But in actual, this is categorical, right? We have a two values only, 0 and 1. It doesn't mean it is an integer value. It doesn't mean it's a data type, although it is converted into data type integer, but basically in real, this is categorical because we have converted it to use the label encoder, and this data set is coming like this. Because when you will download the data set, you have this same format. Okay. They did it actually to for the confidential issues. So the for sorry, not issues for the confidentiality, okay, of the patients. And then here we have the other features too. Now look at the describe method. Describe method is your best friend. It tells you about the idea of the outliers. Its maximum range, its mean value, minimum value, 25%, 50%, 75%. This is we use to look at the basic statistics of the each feature. Right now it is showing the statistics of the each feature because every data type is integer. And then you can see this is the mean 54.3 and maximum value is 77. In case it's 100, this means that this is more than double, right? So your values some lies very far away from the mean, which will tell you there are outliers. Okay, so this is the important thing, most important thing when you are looking at the describe method. And in interview, they might ask you how you will interpret the describe method. Okay, you should know it is showing the standard deviation. You should know the basic definition of standard deviation. This is the way, like it will show you the variance of the data. If you don't know what is it, you can watch my playlist, statistics. Okay, and then this is a minimum value. This is interquartile range actually, 25%, 50%, 75%. Okay. Okay, so now the next is we are just checking this is the basic standard process when we start the analysis. Okay, so here we are just checking using ins and all method if there is any missing value, but the data set is very clean. There is a no missing value. Then we will check for the duplicates if there is any duplicate. then just handle it. Drop it. There is a no use. Your model is not going to learn anything special. Okay. And then here I'm making the changes in the original data set in places equal to true because I have the copied one. Okay. And then we will draw the correlation heat map here. So this is very easy. This is the inbuilt method of the pandas. We will find out the correlation and then just plot it using heat map. This is your plot figure. This is from the matplot. We have set the size. You can make a changes in the set size too. And then correlation, you need to pass the values. Annotation means if you want to see the values on these boxes. This is a cool worm. You can make any color. You will find, you can find, okay. Line width 0.5. This is the one. Okay. And on the right side, this is a color bar. So darker the red color means highly positively correlated. This is 100%, 80%, 60%. And if you see the darker purple color, they are highly negatively correlated. Okay. So now look at this one. This is showing a age. Age is your how much negatively 22% correlated with the target. And here 0.43 positively correlated with the target, highly correlated, right? 43 and 42. This is, you can see, right? This is a color variation. This is the way how you read it. Diagonally, the red one, this is your target because every feature is a highly correlated with itself, right? So that's why it is a showing one. And then this is a check and handle suspicious value in the thal and CA. Okay, so listen this point carefully. Okay, we are working with the healthcare domain data set, right? Although if you look at this data set, you feel like there is a no problem because there is a no missing value, duplicate was one, you have deleted it, and your all information is of the this one integer type, right? No object, nothing. There is a no like the headache to convert it into the integer data type. Everything is already ready made for us when we downloaded the data set, okay? But on top of that, how you can take a deep dive inside it. Okay. All right. So here, listen it very carefully. Whenever you have the like categorical data, right? And it is like contains the different classes. Like here, if we talk about the CA, right? And the thal value, it contains the four different type of the your data. If we go back here, let me find out the CA. This is the number of major vessels, right? So it contains a value from 0 to 3 in original data set. Okay. And it is the type of, it is the value of all these. Okay. And if you, if we want to talk about the thal, I think I did not mention the thal here. So we can find it here. This is the one. So let me find it here. Here we go. So we have for this one, these three type, okay? So I will copy and paste it here too. So it will be easy for you to look later on. Here we go. Okay. So you have a three values in original, right? So it's a good if you check the unique value count for this kind of the data, especially in the healthcare domain. Okay, because sometimes when they are loading the collecting the data set, there are something in your data set which is not like a recognized and it is extra. I have checked every like the unique value of the categorical, but I found the problem in these two. In the thal, it is showing me four different values 0, 1, 2, 3, or sorry, 1, 2, 3, 0, right? Although thal has only three values, it does not have the fourth value, right? So this means, and they are also denoting this one. If we go back here, this is the one. 3 means normal, 6 means fixed defected, and 7 means reversible defect. Okay, but they have like use the label encoder 0, 1, 2, 3. Okay, or you can consider 1, 2, 3. So 0 might be something which is not useful and for the unknown value. And if you are going to use your that value during the model building, it is not going to help the model and it will confuse the model. Okay. And same with the CA. Look at this. It contains only the 4 values. But when I did the unique count of this one to check how many unique values we have, it is showing me 4 too. So this is not like the good value even though. Here, this kind of the, I have checked for in each categorical value like this, but I found the problem in these two, which is showing the extra class or category which does not exist even in my original data. Because I have cross verified it from the original data set, which is here. Okay, so this thing should keep in you should keep in your mind. This is not related to only healthcare domain, it might be with other domain too. That's why it's a good idea to check the unique counts or values whenever you have a categorical feature. This is the wise decision. Okay, and now what action you will take here? This is the second question, right? Either you can convert the 0 into NaN value and you can handle it. Okay. And or both the 0 and 4. Or the second way is just drop the records. Okay. For me, I'm going to drop the records. Okay. Because I'm not sure about it, right? Because this is something which is related to my health, right? We are talking about the patient's health. Even if I handle it using the mode method, it might be not true, right? If there is a less chances, it might not be true, right? So what I have decided, I have dropped it. But tomorrow the data set can be imbalanced, right? And then you might think, Nija, if there are many values, then can we drop, right? Again, this depend upon the ratio or percentage of the data set. You need to talk to the domain expertise again. Okay, so choice is yours. If you want to keep it and you want to handle it, you can. Okay, what it will do, but don't try to handle it with the mean and median because this is not integer data type, right? This is going to be the categorical, so you will handle it with the mode method. Okay, so this is optional. I am going to drop it. Okay, so here you need the domain expertise actually because this is something we cannot decide over on. If you have the knowledge, good knowledge, then you can try, right? Although it seems to be only the 7 records, right? It's a small, but if it costs to the help of the human, this is not acceptable. Okay. So what we will do here, we will see this one I have already written. This is the link I have already shared. So I have checked. It is showing me 48 to 81. This is a record number. And for the TAL, for the CA, sorry, we have a 4 records. So I have dropped it. Okay, I have dropped it. So this is the rest of the records. Okay, now we will move ahead. So this was a very important point actually. That's why I told you we are doing the very deep analysis today. Okay. So I know when there is a no missing value, everybody is happy. Oh, I don't need to handle it. But this can be the another like the part of your deep analysis. If missing value is not there, this issue was there. Okay. So this is the way just I wanted to highlight this because whenever you are working with this kind of data set or maybe any other data set, it's a good habit to check the unique count. Okay. And cross verify you can with the original data set and you can cross verify with the domain expert too, right? What kind of the values are this? I'm not able to understand. Okay. Don't assume yourself. Okay. This is important. And then we will visualize the data set. First of all, we will pick up the numerical features to plot density. Although all features are numerical due to the data type, but we know which are originally actually integer type, right? Because we have a categorical which has converted it into the label encoder. So I have chosen it manually. These are my features. And then I'm using the here subplot and enumerate means we are combining this list. Okay. And then we are plotting the current density. Okay. Using the SNS Seaborn library. So here we go. If you want to learn about the SNS in detail, you can watch my playlist. I have already shared the link in this notebook. Now look at this blue corresponding to no disease. peach color corresponding to has a heart disease. So the age between 50 to 70, most of the patients does not have a heart disease. They are good at health, but the younger people have the heart disease up to 50. See, you might thinking we are not like how it is possible. Maybe due to the stress, due to the lifestyle, due to our food habits, right? So due to that, in today's like the world, we take so much stress, right? This is one of the cause of the heart attack. Okay, lot of workload, lot of responsibilities, junk food, lifestyle, late sleep, early wake up, right, for the work, something like that. Okay, so they are more survival than the younger people. And then here, look at this. This is your the I think it was a TRES BPS blood level sugar. I think let me recheck it. Yeah, resting blood pressure. Okay, so this is the blood pressure. The blood pressure range, when the blood pressure range is between we can say 90 and peak values is between 150, they have the more chances of heart disease. But there are some values where even the patient have the 200 the blood pressure disease like the level, they don't have the heart disease. It depend, right? It again depend on the, it is a collection like the depend upon the other features factors too, their food habits, their stress level, sugar level, everything, right? So this is giving us a very clear picture. And then look at this one, cholesterol level. So here, if the cholesterol level is between 150 250, this is the chances of heart disease. But if it is even start from the 100 and it is going to the 400, there are less chances of no heart disease. So there are some people, right? So this is this kind of the data we have. Okay, this is showing the data distribution based on the each your different vectors. And you can go through this one too, right? So like this is a like the you can see again in the data dictionary what does it mean. Okay, so this is showing here the maximum heart disease chances we have the 150 to this 180. Okay, and this is from the old peak. All right, so I have drawn this one graph, but you can draw this graph too. What I did, I have just to pick up the use the cut method to cut it and converted it into the groups, the bin size, and then I'm plotting the histogram, sorry, count plot. Okay, so this is also the more clear version. It is telling you between this and if the age is between 50 and 60, there are high chances of patient have a heart disease or no. Okay, so if the age is between 72 and 80, this is the less chances of the heart disease and high chances of have a heart disease. No heart disease, heart disease. So this is more clearer, right? Here it is overlapping. Sometimes stakeholder does not understand the meaning of this overlapping. Okay, they might get confused. This is good graph for you, but this might be very beneficial for your stakeholder. Okay, you can have the deep and like the look at this when you are like watching looking at the notebook too. Okay, this is very easy to read. And being a data scientist, being a data analyst, you should be able to interpret it in a very good way. It should have the proper legend, title, and this one. Okay. Now we will move ahead for the data distribution using the categorical feature. Here for the categorical feature, I have converted it into the label name so we can understand it in a very good way. Okay. Look at this. I created a new copy because I was actually renaming the column names. I did not want to touch this one. This is temporary. Okay. If you want, you can make a changes in hard DF too. But later on, you need to convert it, transform the data again. Okay. So I'm avoiding that step because my data is already transformed into the integer, right? They have already converted it into the label encoder. To avoid that situation, I did this. Okay. So I'm converting 0 to female, 1 to male, what we have given in the dictionary. Same for the CP. This is the name. And then we are plotting the again subplot, count plot. Look at this. So it is showing the gender. The male have the distribution of the data about the 201. In our data set, 201 records of the male who have like the records who might have a heart disease or not. Okay. So we have how many female records? 95. Okay. And this is showing the records of the different type of the chest pain. Okay. So most of the records we have the typical angina pain. Okay. And this is for the fasting blood sugar. Okay. So we have the records less than 120. Okay. More 253. So this is showing the distribution of the categorical feature, whatever you have. Okay. So you can look at it this. This is a CA level. Okay. And this is the target. We have the around 160 records which says heart disease, and 136 records says no heart disease. Okay. So you can also have a look for the others graph too, but this is very easy to like the understand, interpret it. Okay. And now we will move ahead. Box plot of age group by target. This is another very, very useful graph. It will give you the very clear picture like about the age distribution by the target. So what is that? We are using the box plot here. On x-axis, we are showing the 0, no disease, 1 heart disease, and the age on the y-axis. So look at this. First of all, we will look at the box plot. This is minimum range, this is maximum range, and the dots which you are looking at it, this is called outliers. Remember in the describe method I told you there is an interquartile range, minimum, maximum, this is that. Okay, so here you can see minimum range. So the age is starting from the, you can say 25 to 40. There are still cases they don't have the like the no heart disease, right? And the age between the 55 to 60 or 65, right? The patient does not have a heart disease. But there are some outliers too. The people who are older than 70 years, even they don't have the heart disease. Okay. It again, I will say, depend upon the habits. Okay. And but if we look at the, if the patient have a heart disease, what age factor is? You can see younger people are showing more, right? So between the 30 and 40. But here you can see, and this one too. Okay. But the median is showing between 50 to 60 here. Okay. So this is the way how you can show the distribution of the age by the target too. Like at what age the people can have the heart disease, or at what age people cannot have the heart disease. But there are no outliers, right? Now look at the next graph. It is showing the cholesterol distribution by heart disease. We are showing what are the like the value of the cholesterol when the patients might have the heart disease. Okay. And in our data set, look at this. If the zero, this blue color is no heart disease, this is speech is this. So let's look have the heart disease, because we are more interested to give the treatment to the people, right, who have the heart disease. So if their cholesterol levels between, you can say 50 and it is going up to 200, they have the more heart disease. So they should be take care, and then it is going down, right? And then the people, the cholesterol level even between 300 to 400, they don't have the heart disease. Okay, so this is what it is showing. This is called your the graph histogram plot, and it is showing that this bell icon is bell curve shape is showing the KDE, kernel density. Okay, and then you can also plot the pair plot too. Pair plot is very easy. You just say the SNS pair plot and it will, you can pick up the all features. Here we are picking up the all your numerical feature, and it will show you the correlation too. If you come down, look at this age between old peak. Okay. If the age is increasing, does the old peak is value is also increasing? Right? So are they are going to contribute equally for the prediction of the heart disease or not? Right? So this is showing the relationship, okay? And it is the relationship between Thorlac and Old Peak. And this is between the cholesterol and this one. And diagonally, you can see this is a kernel density, right? Bell curve shape. Okay, so this is showing the relationship. This is very, very useful graph too. And the hue effect we have added for the target. Red means no heart disease. Blue means has the heart disease. Now, if the age and your old peak is increasing, does it increases the chances of your heart disease? One. So we can assume the blue dot is maximum coming here up to the 4, and age is showing 60, and even the age is above 60, but there is a no old peak value. This is less, even the patients can have the heart disease. Okay, because blue sign means have the heart disease, red sign means no heart disease. But if you look at these 2 points, this one, the old peak value is high and the age is also, or like a middle, right? 55 to 60, they don't have the heart disease. Okay, so this is showing you the relationship between how the two features are contributing in prediction or having the heart disease or not. Okay, so this pair plot is very, very useful. Another graph. And then we will move ahead. We can have the look between the gender versus target too, because we want to know either the male has a high risk of heart disease or not. Okay, so look at this result. Again, the red means no disease, blue means has the heart disease. First, look at the female. If the female count is between 65 and this is a no heart disease, less count, right? So the female might have the heart disease, but you can look at the male count. If you do the comparison between the heart disease, have the heart disease between the male and female, the female has the less chances than the male. So male have the more problems of the heart disease because this count is higher than your female count. It is above 80. Okay, but on the other side too, right? And then stack bar chart. This is a chest pain type versus your target. So what kind of the pain have the high chances of the heart disease? So here I'm using the PD cross tab for the chest pain type, and then we are normalizing the index, then we are plotting the stacked bar. So this is your typical angina type. Yellow means heart attack, no heart attack green. Okay, so if the proportion is up to 70%, no heart attack. There are small chances. If the patient have this kind of the chest pain, there are less chances of heart attack. But if they have the this much atypical non-angelica and asymptomatic, they have the chances of heart disease, right? Even it's of below 20%, even they have the chances of heart attack if they have these any three of the chest pain. Okay, so this is important. So this graph is very, very useful for your stakeholder too. Okay, so you need to think a lot when you are drawing the graph actually. That's why I'm showing you the very detailed graph today in this video. But if you come up with any other graph too, you can draw. Okay, and then here, this is what I was talking about. This is the confusion matrix. We are using the chi2 contingency and then F classifier and label encoder. Okay. First of all, we will separate the categorical numerical feature. Then I'm making the again copy here. And then I'm showing first the numerical Pearson, which I have showed you the above two. Okay. This is that one. So after that, I'm showing the categorical versus categorical. We call it Cramer's V2. Okay, this is Cramer's V. It will show you the association between the two categorical features. And the value is between 0 and 1. If it is close to 1, this means highly associated the two categorical features with each other. If it is close to 0, weak association, no correlation, and it will not help you to do the good predictions or classify the features. Okay. And then here we are using the Cramer's result as type. We are converting into plotting this one. And then this is a NOVA test between numerical and categorical. If you have the here higher value of the NOVA, I will show you at the bottom. Here we go. This one. If F score value is a higher, and then what will happen? Those features will help in the prediction, classifying the your class correctly. Okay, high chances they have the more contribution, 66%, 65%, 15. This has the weak chances. It is not going to classify your whether the patient have a heart disease or not correctly, because this is a very weak relation with your target. And if the p value is less than 0.05, okay, then that value is going, but it doesn't seems to be any like the less value. Okay, this is a p value. This is called ANOVA F test result. Okay, you can do it. I just wanted to show the deep analysis actually. That's why I am saying you. If you found any like the weak relationship based on the p value or might be based on the this F score, you can drop it too. You can keep it and drop it too. I'm not going to drop it, but if you want, you can drop it. Okay, and then you can fit the model again and you can see the difference. Okay, I will show you the now here heat map. This is a numerical feature collection. So look at this, age is 20%, right? Highly associated. And then this is your blood pressure. This is a cholesterol, very less, right? Thyroid is negatively correlated. This is the old peak is 100%. Okay, associated. And then here it is, I told you the value is between 0 and 1. So 0.99 means it is close to the 1. So this is highly associated with the target feature. Target is also categorical feature, right? This is also categorical gender. See, okay. And if you look at the CP, this is 51% highly associated with the target. And then with the 50% CA, thol, and this one. And also this one, ZAN. Okay, this is less. Fasting blood pressure, sugar, it is showing 0. Very weak correlation, association with this your features. Okay, so this like the heat map you can draw for the categorical association. Okay, especially if your target feature is categorical. We used to draw the Pearson only, that is only for the numerical, but this is I wanted to show you today, especially for your healthcare domain data set. Okay, so these all features which has a value close to your 1, those features are helping to classify the results more correctly, more predictive features. Okay, so what are the more predictive features now? Old peak, thallic, and age. This is I'm writing from the above the numerical, but you can see here their F score is very high. So that's why I have written it. These are the most predictive for the heart disease classification. So this is showing the association too. Okay. And then we have the build the model. Okay. So now what we will do, we will start building the model. We have built the model using the 3 different models as I told you earlier. We will import these all libraries, which is mandatory, trade test splitter to split your data set, then standard scaler to scale the data numerical, and then this is a matrices. This is your all classification matrices. This is not used for regression. Okay. And then this is a Seaborn. I have posted this on because I'm going to draw the raw curve, O curve, F1 score, recall, precision score, and accuracy score too. Because never ever rely on the single number of the accuracy in classification problem. Because that is only the just single number. Confusion matrix is mandatory as per my experience, because it will give you the clear picture how many like the classes you will be classified correctly. If there are 100 cases the patient have the heart disease, does your model able to predict 100 cases correctly or 95 cases correctly? So you will understand the false positive, false negative classes, which is very important. Okay, and then we are importing the logistic regression random forest IgG classifier for our today's model. Here I'm just looking it at again. Now we will separate the your X features and Y. So from the X feature, I'm dropping the target, age bean, cholesterol bean, thallic bean, because I have created it for my visualization. Remember above when we're drawing the graph. Okay, so I was creating it for that one. Okay, so we will drop it because we showed the bin graphs right above, and then this is the Y target, and then we will use that get dummies to encode the categorical feature. Now you are thinking, Nija, why are you using the get dummies? This is already converted into the label encoder. But you know what is a like in the label encoder, when you have the four classes 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. What is the reason? When your value is 4, your model might think its magnitude is very high. I should give the priority to this one. So your model might become biased. To avoid that scenario, or this is all categorical, we will use the get dummies. Okay. So it will give the equality, because in the get dummies, we only have the 0, 1 value. Okay, so this is the reason. And then we will do it, and we will drop first is equal to true, because the last column, the first one, if nothing is come up by default, it's a 0 or 1. So we will drop them. And then we will train and test split. Here we will scale them. And then we will fit onto the train and transform the data. Okay, we have scaled it. Okay, this is not we are fitting, because we never fit the test data, otherwise there will be the data leakage. And then we will create the dictionary for the different three models, so we can apply it collectively. And this is the metric list: y predictions, y probability, to save over all values. Probability percentage, prediction means yes, no, only two values. Okay, and then confusion metric, we are writing the code for the confusion metric here. And here we are doing the prediction. This is we are saving, this is the results value. Now look at the result. So this is your logistic regression. So no disease, actual value is no disease 24, and my model was able to predict correctly here the 24. Okay, the no disease 24. Okay, and now here the disease, the actual value of the disease is your like the 28, and it is able to predict 28 correctly. Okay, but it is saying 4 not correctly. Okay, so this is saying, this means 4 value is incorrect. The patient have the heart disease, but my model is saying no, they don't have the heart disease. So in this case, now think about which problem you which type of the like the confusion matrix, like false positive, false negative, right? On which type of the confusion matrix you will give the priority. Okay, what should be the most important in this kind of the data set? Just think about it and drop a comment right now. Okay, I am saying this is your false positive, false negative, right? So confusion matrix give us the true. We have four values, right? True negative, true positive, false negative. So true negative is this, right? So that there are a total 28 values for this one too, but it was able in actual you just assume 28 values, and your machine is also saying yes, out of it 24 they don't have the disease. Okay, they will start getting the treatment, but again they have a might more test, and they will be say no, you don't have the heart disease. That is fine, but here this is true, this is your true negative, right? And this is true false negative, right? It's a no, sorry, it's a false positive. Okay, in this case this is false negative, this is true positive, right? So our goal is to reduce this value, this one, because if the patient have the disease, your model also say they have the disease, because they need immediately treatment, right? So we can start giving them the medicine and the treatment so they can be healthy. Okay, so this our goal is to reduce your false negative values in this case. Okay, this is your true positive, right? We will increase this, reduce this. Are you getting my point? Because if the patient have the heart disease, your model also should say they have the heart disease. It should not say no, they don't have the heart disease. If it is saying that they don't have the heart disease, even in actual they have the heart disease, that value is known as false positive. Okay. So this is you need to take care. But in case of random forest, it is increased. We don't want that, right? In the XGBoost, it is increased more. Okay, so our goal is to just reduce this one. Okay, because we want our patient should not have the heart disease. Oh, sorry, they get immediate treatment. Okay, this is important. And this is, we can look at the accuracy level too. Logistic regression at 86%, this is 83. XGBoost is this, right? And in this case, you can see the recall too. We want the high recall in this, right? Because we want to recall means which help you to predict correctly, which were actually correct. Or you can say recall means it will a high recall means the values which were actual positive, your machine is also saying it's a positive. Okay, that is recall. So this is important, and this is F1 score. Okay, so that's why I'm telling you, whenever you are working in the with the classification problem, always draw the confusion matrix, because it is giving me the clear picture, but accuracy is 86%. I don't know how many cases are false positive, false negative. How would I evaluate my model in that scenario if I'm only looking for this value? I'm not drawing any confusion matrix. It is important. Okay, so this is very, very important. And then here we are just drawing the raw cock. Okay, so raw cock is also the very good method to look at the how your model is performing actually. Okay, so I have drawn for all three graphs. Your blue line is for your logistic regression. This is your middle. Below this, model is dumb. Okay, this is a false positive rate. Okay, this is false positive, this is true positive rate. This is what we want, right? And the high recall. So here this is area under curve, this one, AUC. AUC means area under curve. Now look at the blue logistic regression. It is a start with this here bending and then going, but it is going here one. Okay, this is near like your 100% accuracy, right? And then this is your random forest. This is covering less area, right? But your logistic regression is covering more area. Let me open my annotate. So look at this. So your blue line, it is covering more area, right? This one. But your orange line is covering less area than blue, and green is less covering less area too, right? So this is, we need to look at it. So we need to increase this one, true positive rate. Okay, recall. And we need to reduce this one, false positive rate. Okay. And then here we have the, now I will show you the feature importance. Okay, because we are done with the fitting model, we have done with the confusion matrix, we have a look at the values, we have evaluated, right? And then I just wanted to show the feature importance, which model has used what feature most of the time during training. Look at this age, it is coming on the top. So this means this is a highly like the most predictive feature for your this kind of the problem. The orange color means the random forest is used most of the time. You can see the importance feature. This is more than 80% important for the random forest. But logistic regression has used it only up to 15%. And XGBoost only less than that. Okay. But age is at the top. Okay, and then your blood pressure, sugar level, this is logistic regression has used most of the time. Okay, and then you can look at for the random forest, this one. So you can see there is a very difference, right? Your XGBoost is using very less. It is using CP level 3, CP3, chest pain type 3, to predict whether the patient has a heart disease or not. And your logistic regression is also using that. Okay, so how the logistic regression work? Logistic regression work based on the coefficient values, right? And random forest works based on the decision tree, multiple decision tree, right? And XGBoost, what it does, it is also using the boost the features, right? It is all like based on the in assemble method, sequential and other one. I just forgot the name of that one. So this is using these features used by your all three models. I just wanted to show you the comparison whenever you are when you are fitting the model during training, which feature was used, up to what percentage, what proportion your each model. This is very good understanding because it will tell you which feature you can keep even and you can refit the feature again. Okay, look at this. Your random forest is using this one very less. Even your logistic regression too, right? So you can try to drop this feature and fit the model again. You can keep only the feature which is very high. Look at this one. And then fit the separate model again and again. Okay, might be your accuracy will increase from 86 to 90. Okay, so this is the important portion. Okay, and then the last is we are saving the model. I'm using the job lib and then using the pipeline and SQL and pre-processing so I can process the new data set too whenever we are giving the new value for the prediction, and then we will save the file with the pkl, and whenever you run this it will be saved with this pipeline. Okay, I'm only saving the model with the logistic regression because this is giving me the highest accuracy, and even in the confusion matrix it is able to like a less false positive cases, right? False positive cases, right? So that is the less cases. Sorry, false negative cases. Sorry, false negative cases, right? Because a patient has a heart disease, but your machine is saying no, they don't have a heart disease. So it's sorry about that. So this is the best model we as per over analysis, and we are going to use this one to save the model. Okay, you this is just I wanted to show you the overview, deep analysis, feature importance, confusion matrix, and what strategies I have followed. If you want, you can make changes in this. You can fit the model again. You can hyper tune your model, your random forest or XGBoost, and you can try again. You can also like the logistic regression to hypertune. Okay, you can make changes in the value, but we have a lot of stuff to do. Otherwise, the video will go very long. Okay, just let me know which method you have applied extra. Okay, and who is doing the practice as I suggested you in the start of the video. Okay, just drop a comment, and I will definitely help you if you are stuck in somewhere. Okay, and now we have saved the model. Okay, so when you save the model it will be here. You can download this model file. Okay, because now we are going to prepare to deploy this model. Okay, now come to this one, Streamlit. Okay, I have showed this one how to register and everything in my previous video. This is very easy. You just go to the here playground, this one, click on the free. Okay, I'm already logged in, so it is not asking me for sign up. You can sign up very easy and you will come here. Okay, but before doing that, it is important you need to create a GitHub repository. There are three ways to connect with the Streamlit. GitHub, there is a Flask or other one more method. You can connect it with the other methods too. I'm using the GitHub. Okay. So here I have uploaded the py file. Okay. So now you are thinking, what is py file? Py file I have created where I have written my Streamlit code. Okay. I will show you. Look at this. So this is also a Python file, but whenever you are downloading from here, just click on the file, download py. Okay, this is the application file. Otherwise, your Streamlit will not understand IPYNB. By default, even you are working in the local environment, it is saved as a IPYNB by default. But you need to save the file with this one. But don't write this code. I'm not saving this file as a PY. The code is different for this one. This is the one. So we will import the Streamlit, Pandas joblib, and this is a model. We are loading the model again. Expected feature. We are making list. This is the code for your Streamlit front end. Okay, I will definitely share this link, the GitHub link, with all of you. You can download the file. You can make any changes here. Okay, you can read the documentation of this one. They are giving the very good like the here the definition. You can just read the documents, how to add the sliders and everything. You can make a beautiful your front end. Okay, I made it very simple, but you can. Okay, and then on the GitHub you need to keep in the repository. I have created the repository. I uploaded py file requirement.txt. You need to mention all libraries here on which your model is dependent, right? We have used pandas, streamlit, scikit-learn, these models, right? And then we have used a matplot. Even if I have mentioned the XGBoost, I did not mention the logistic regression. We don't need it because our model will handle. Okay, but the scikit-learn, joblib, pandas, numpy, matplot, seaborn is important. Okay, because the libraries which we are mentioning here in the your py file, these three, this is you need to mandatory like I mentioned in requirement. Okay, this is mandatory. Even if you write the all libraries, there is a no harm. It will take some time to install all libraries by default. Okay, because it will create the environment to run your model. Okay, and then that's it. You don't need any extra file. Okay, only two files. Your this is the one and this is the one. Okay, I'm using actually here. Sorry, I forgot. This file you also need to upload the model file we saved. Okay, so this is important. So three files you need. Okay, so the first file is your py file in which you have written the all Streamlit code, the front end code, and requirement txt file where you will import the all libraries which you want your Streamlit should be installed to run your model. So these three one, okay, I have mentioned many like the libraries, there is a no harm in that. Okay, and then this is your model, the model you have saved, okay, which we have downloaded it from here. That's it. You needed three files only. Okay, sorry. And then you can click on create app. I told you you can deploy a public app from GitHub. You can app from the template. You can private app in the Snowflake. Okay, so here I'm using this one. Okay, if you want, you can use this. This is a paid. You will find the start free trial for some days. I never tried it, but you can try. But this is also good. Okay, this one. If you want, you can also choose this one. Okay, to like for to sorry, to deploy your model. Okay, and then here we go. When you will create deploy like a create app, just deploy now. Here you need to copy and paste your repository. My repository name is heart disease. Okay, and then this is the main branch. Okay, after that my file path, my file name is this, the py file. I told you we have created it, right? And then I will set it, and that's it. It's very easy. Now you will click on the deploy. When you click on the deploy, it will show some icons, keep on running. Okay, don't worry, it will take few seconds and that's it. I'm not going to deploy it again because my application is already seated there. So I will cross this one and we will come here. Okay, once your file is deployed, model is deployed, it will look like this. Okay, it will look like this. So HTML, you can make a changes. If you want to change this HTML, you want to add the more like the user-friendly slider, changing value, you don't want the input field, you can add. Then you need to make a changes in the py file. Okay. And here, if you click on this manage one, you can see here, this is the one. It is showing process dependency, pulling the code from the GitHub processing dependency updated app. So it is also showing what libraries it has installed. Okay, so it has created the environment 3.313 and it is installing the 50 packages for this one to run. Okay, so this will be by default. That's it. If you want to make any changes, you can also manage the app here. Okay, you will click on that. You can download the log, how it is going to like working, what steps were followed, and it is a reboot app. You can also reboot it if you are making any changes, it is hang, right? Stuck, you can do this, and you can delete the app from here too. Okay, this is all about over this one. Now let's see. You can add the age like these. You can change the value in this cholesterol level. You can add the value. Okay, so chest pain, I would like, we have seen chest pain 3 was used, right? So we will make this one enable, and you can use this one, this one. You might be thinking why it is showing this one too, because this is one, we have converted it into the one hot encoder, right? Dummy. So it is picking up all features from the pipeline. That's why. Okay. So I'm using the same features, and then here this is the this one, chest pain type 1 or 2. You can choose this one, right? And then predict. So it is saying high risk of heart disease, 76.62 probability. This will be the output. Okay, so this is a deployed model, and if you want, you can share this link publicly too. There is a no harm. Okay, and it will be seated in a very good way. Because whenever we are deploying on the cloud server, I have already made the videos using the Amazon server EC2 Docker file. It keep on spending your free tire actually. Okay, but this is not the case here actually. Okay, so this is good for the startup. Okay, it is easy to deploy, understand the process, that's it. Okay, and now your model is ready. Okay, if you still have any question, right, and you are stuck in somewhere, then just let me know. But the deployment on the Stringlit is so easy. You only need to prepare the py file correctly. Okay, just keep in your mind, write only the code which you want to display at the front end to the user or to the stakeholder. Don't write any extra code in the py file. I will share the link of the GitHub with all of you. You can just copy and paste, upload onto the GitHub, and you can make changes according to your requirement. And you can use the file or look for the documentation. You can create it very easy way. Okay. So this is all about our today's video. And I would like to answer the now today's question. In my previous video, I have asked one question, why we are not using the one hot encoder for the your qualification conversion into the numeric for the dataset AI job posting classification. Why I'm using the label encoder? Why not using the one hot encoder? The answer is labeling. If you have the limited classes, you can use the label encoder, right? The one hot encoder will create many columns features because that data set was already very big. So we avoid it. Okay. So this was the reason. And you can do the experiment too. This is all like experimental. If you want, you can convert it into one hot encoder and then fit onto the model and then see the difference, right? Because till you don't implement, you will not get the results and you will not learn. Again, I'm saying, if you are watching this video, always watch the video. Open the window in a one side, my video, open on the right side, other your window, download my notebook, just match it. Okay, and if you want to add something come up in your mind, we can do like this way too. Just create a new cell, just write down quickly, pause the video, take the break. It will take you 1 day, but after 1 day you feel very confident. Okay, believe me, this is the best way you to learn. And if you have any question, I'm always there. Drop a comment. Keep patience, keep learning with Science Data Science. See you in the next video. Thank you so much for watching this video. Thank you.